All right, so today we're doing the combinations classwork. And the one thing to know about combinations is that the order does not matter. So the order doesn't matter when we're talking about combinations. So let's take a look at the classwork, and we're going to do the odds number together, 1 through 10. Number 1 says we need to list all the possible combinations. So it tells us to list all the possible combinations of these three numbers, 1, 2, and 3. And they need to be taken 2 at a time. Okay, so I have these three numbers, and if I take them 2 at a time, then I can have 1, 2. I can have 1 and 3. And I can have 2 and 3. Those are the three combinations that I can choose from. Now, since I can't change the order of 1, 2, I would just get 2, 1. But since they're equal, I don't have to list the reversals. So I don't have to list 2, 1 and 3, 1 and 3, 2, because when you deal with combinations, the order is not taken into consideration. So 1, 2 is the same thing as 2, 1. So there were three possibilities. How did we know that there were three? Well, we can use the combination formula, right? So the combination formula is going to be n choose r, where we're going to have n factorial at the top of the fraction. And in the denominator, we're going to have r factorial times n minus r factorial. So if we were to plug in the numbers that we need, we know that the total number is going to be n. How many numbers do we have? 3, right? How many can we choose? That's going to be our r number. We can choose 2 at a time, so r is going to be 2. And now we just have to plug n and r into this formula. So we're going to get 3c2 is equal to 3 factorial on top of the fraction. And then on the bottom of the fraction, I'm going to have 2 factorial times 3 minus 2 factorial. So when I work this out, I know that 3 factorial is going to be 3 times 2 times 1. And then in the denominator, I'm going to have 2 factorial, which is 2 times 1. But then I also have 3 minus 2, which is actually equal to 1. And 1 factorial is just going to be a 1. So what happens is we can cancel out all the common factors on the top and the bottom. The 2's are going to match up, so I can cancel those, and these 2 1's are going to match up, leaving me with just a 3 over 1. And 3 divided by 1 is 3. So I know that I'm going to have 3 separate possibilities when I take the numbers 1, 2, and 3, and I try to put them in groups of 2. Okay, let's look at number 3. 3 says evaluate 13C11. And we're going to be using the formula n choose r is equal to n factorial divided by r factorial times n minus r factorial. So we're going to have n be 13. So we're going to have 13 factorial on top. Then we have to have r factorial. That means I'm going to have 11. factorial. And then in parentheses, I'm going to have 13 minus 11 because I have to subtract them, and then put the factorial on the outside. So now 13 factorial, I can write that as 13 times 12 times 11, but then I don't have to go all the way to 1 because I can stop at 11 right here. Just remember to put the factorial at the end. And then in the denominator, I still have 11 factorial, and 13 minus 11 is going to give me 2 factorial. So now what matches up on the top and bottom? It's going to be the 11 factorial. And 2 factorial, that's the same thing as 2. So I'm actually going to have 13 times 12 divided by 2. 13 times 12 is going to give me 156. And then if I'm dividing by 2, then that's going to give me what? 78. That's going to be my answer. Let's look at number 5 now. I need to evaluate 13 combination 3. So 13, choose 3. So I put the 13 as inside the formula. That's my total number. So I get 13 factorial at the top. And I'm going to be dividing by 3 factorial. That's my r value. Times n minus r. That's 13 minus 3. And then I put the factorial on the outside of the parentheses. So now 13 factorial, I'm going to leave at the top for now. I know that I still have 3 factorial at the bottom, and I also have 13 minus 3, which is 10. So I'm going to have 10 factorial. I want to cancel out the 10 factorial, of course. That's the closest number to 13 that I have. The 3 is a little bit far away, so I'm not going to deal with that yet. I know that 13 factorial can be written as 13 times 12 times 11 times 10. But then I don't keep going to 1 because I'm going to put the factorial on the 10. So that way, the 10 factorial at the bottom can be canceled out. So now I have 3 factorial times 10 factorial at the bottom. And that 10 factorial is going to cancel out with the 10 factorial at the top. So at the top now, I have 13 times 12 times 11. And that's going to give me 1,716. So 1,716. And I'm going to be dividing by 3 factorial, which is 3 times 2 times 1. I know that that's going to be 6. So if I divide this number by 6, I'm going to get 286. All right, let's do 7. This one says Crystal has homework in 7 subjects. She only has time to do 4 of them. So we're given 2 numbers, 7, that's going to be my total, my n value, and we have 4, that's going to be my choosing value. So I'm basically taking 7 subjects, and out of those 7, I'm choosing 4 of them. So that's going to be 7 combination 4, 7 choose 4. So putting that in the formula for combinations, we're going to have 7 factorial at the top 4 factorial at the bottom, and 7 minus 4 factorial. So what happens is 7 minus 4 is going to give me 3. So rewriting this, I can have 4 factorial times 3 factorial at the bottom. So for 7, I'm going to write out the factorial until I reach 4, and I'm going to stop. So 7 times 6 times 5 times 4 factorial. Stop right there, because in the denominator, I have 4 factorial times 3 factorial, which is going to be 6. So now what I can do is I can cancel out the 4 factorials on the top and the bottom. I can also cancel out the 6 with the 6, and I'm left with 7 times 5, which is 35. And that's my answer. Okay, and the last one we're going to do together is 9. So this one says a group of 30 runners are going to run a race, and the top 6 finishers are going to go to the finals. Top 6 finishers go to the finals. So I need to know what my total number is. That's going to be this 30. And I need to know what my choosing number is going to be. That's my 6. So now putting it in that combination formula, I'm going to have, out of a total of 30 runners, we're going to choose 6. So it's going to be 30 combination 6. So putting it in that formula, I'm going to have 30 factorial over 6 factorial times 30 minus 6 factorial. So that's going to give me 30 factorial on the top, not changing that yet, over 6 factorial times 30 minus 6, which is going to be 24 factorial. So now what I want to do is I want to cancel out the 24 factorial. The 30 can go all the way down to 24 and then stop. So I will do that. Stop at 24. And then in the denominator, I'm going to have 6 factorial times 24 factorial. The 24s can cancel out, and the 6 factorial can be rewritten as 720. Because that is 6 factorial. And now I have all those numbers on the top. They're going to multiply to give me, using my calculator, so I stop at 25. That's going to give me a really big number of 427518000. So this would be in the millions. And I'm dividing by 720. So doing that in my calculator, I'm going to get 593,775. So that's the total number of combinations.